It's a pleasure meeting you all in another video. In this video, I hope to discuss about friction. So, what is friction? When two objects are in contact with each other, when one of the object is moving or has the intention to move, remember, with respect to the other. So, with respect to the other, then let's say this has an intention to move or is moving along this direction. An opposing force is developed to oppose this motion or the intention along this direction. This force is known as the frictional force. By now you all should have known what is friction but still might have doubts in marking the direction of friction. Let's go through a few examples to understand how to mark the frictions clearly. Example 1. Two boxes are kept in contact with each other. The box above is moving with velocity v and the box below is also moving with velocity v on a smooth surface. Here, according to our discussion, there is no relative motion between these two blocks. This block is at rest with respect to this block and it has no intention to move beyond that. They are moving with the same uniform velocity. Therefore, the friction between them is zero. There is no friction between them. Let's look another example. Example 2. A box placed on a rough horizontal surface is being pushed by a force of F. And let's assume this box is moving along this direction. So, to oppose this motion, is moving along this direction. To oppose this motion, a frictional force acts along this direction. A frictional force will act towards left side. Let's look one more example. Example number 3. A box A is being placed upon box B on a smooth surface. Now let's assume that the box below is being pulled using a force F and there is no any relative motion among them, but they are in acceleration. Each of them are in acceleration. So does this imply the frictional force between them is equal to 0? Remember, this box B is being applied, a force F is being applied on box B, and this box B has an intention of moving away from A due to this force F. So what is its intention? Its intention is to move away from A. Then how will it be opposed? Box B is being pulled by a force F. Its intention is to move away from A. Therefore, the frictional force will act along this direction. According to Newton's third law, there will be a equal and opposite reaction acting on the other object. Therefore, on the box A, this frictional force acts forward, and on box B, it's backward. And remember, this frictional force are going to act. This frictional force will act as the unbalanced force required to move this object, and the resultant here will act as the unbalanced force required to accelerate B. Let's look few more familiar examples. Example number 4. Let's think of a situation where you are on a bus, standing on a bus at the center, and the bus is initially at rest and it suddenly accelerates. Its velocity is going to increase in the forward direction. You are standing here. So initially the bus was at rest, now it is accelerating forward, and you know by experience you will be pushed backwards due to inertia. In relative to this bus, what is the direction of motion? You might have not moved, but you might have an intention. Due to that sudden movement, you might have an intention of moving backward. Then the friction is going to be in the forward direction. It will act in the forward direction. I hope by now you must have a better idea on understanding the direction of friction. So you can consider in two ways. First, using the relative motion, so you can identify it directly. Other one, if there is no any relative motion, you can think of in which direction it tends to move. So using that, you can find the direction of friction. Example number 5. Let's think of a ladder that is being placed on a rough floor and on a rough wall. What will be the direction of frictions acting here and here? How can we think of this? The ladder, in which direction it tends to slip? Does it slip into the wall or away from the wall? For sure, it's going to slip away from the wall. Its intention is to slip away. Then, what is the direction of friction acting right here? As it tends to slip away, the friction will act towards left. How about the friction right here? When the ladder slips away, this is going to come down. So at this point, the intention of the direction is downwards. Then the friction is going to act upwards. By now, I hope you should having a better idea on marking the direction of friction. So let's move on to our question. It says a lorry is accelerating with 5 meters per second with a box placed on its bed truck. We must find the force on it. Let's find out the direction of friction initially. If this lorry is accelerating towards right, as we have discussed, due to inertia, this box tends to move backward. Due to inertia, it tends to move backward. So, to oppose this intention, the frictional force will act along the forward direction. Now, question, it says 1 kilogram box lies on a horizontal surface with coefficient of static friction between the surface as 0.6, and they say the truck is moving with 5 meters per second minus 2. And so let's mark those information. To find out the value, let's look at one important concept: types of friction. Let's think of a 5 kilogram box that is being placed on a rough surface whose mu between these two surfaces is equivalent to 3.3 and 10 newtons force being applied on the box. Now we are supposed to find the friction acting here. We know the equation of friction, that is F is equal mu R. So mu is 0.3 and R is 5 newtons, sorry, it's 50 newtons. Then it's going to be 15 newtons of frictional force. So is the friction acting here 15 newtons? Think it a bit. If the friction was 15 newtons, what will be the resultant force? Would it be 0 or 5 newtons? It's going to be 5 newtons. Thus the box cannot be in equilibrium. It's going to move rightwards. To be in equilibrium, the force has to be 10 newton instead of 15 newton. If it was 11 newtons, then to be in equilibrium, it also has to become 11 newtons. Then what is this 15 newton? According to what I said previously, you should have understand one thing. If the force is 12 newton, this also becomes 12. If this becomes 13, this also becomes 13. So the friction is also gradually increasing. Then you call those types of friction which adjust according to the situation. When I apply 11, this also becomes 11. It self adjusts. So these types of friction you call the static friction. The static friction will adjust according to the situation to keep it in equilibrium. Then what about this 15 newton? 15 newton is the maximum friction, that is the limit. Beyond that you cannot have a friction. So if you increase the applied force up to 15 newtons, this static friction also will increase up to 15 newtons. Once you are applying 16 newtons of force, the maximum force, the maximum friction is just 15 newtons. Now the box would start moving. Under this, you call the acting friction, it is going to be lesser than 15, a little lesser than 15, and you call that friction the kinetic friction, and the maximum friction as the limiting friction. So the equation you use here will find you the limiting frictional force, that is the maximum limit of frictional force. That doesn't mean that if you apply 10 newton it has to be 15 newtons of friction. I hope you understand the difference between static and limiting friction. Now let's come back to our question. Here also it's the same, and this frictional force is going to act as the unbalanced force to provide it the acceleration that is equal to the acceleration of the lorry. But as we have discussed previously, this frictional force can increase from 0 to certain limit, fl. Beyond that limit, this friction cannot provide more force, so this box will start sliding backward. To accelerate the box with 5 meter per second, what is the required unbalanced force? How can we find it? We know that F is equal to ma. By substituting m with 1 and acceleration with 5, I obtain that F is 5 Newton. The required force to accelerate this box at acceleration of 5 meter per second is 5 newtons. We had an information 0.6, so fl is 6 newton. By calculating using mu r, I obtained 6 newton. From this, what can you understand? The required force is just 5 newton for the moment, but the friction is capable of providing 6 newton. Therefore, move without sliding with respect to the lorry under this situation. The acceleration is 8 meter second minus 2. Then the required force F is going to increase up to 8 newtons. If the required force is 8 newtons, the box will start sliding backward because the maximum force the friction can provide has been 6 newton and the required is 8 newton. As it cannot provide the 8 newton force, the box is going to start sliding backward. The question is, what is the frictional force acting right here? The frictional force is not 6 newton, the frictional force is 5 newton, and static frictional force is observable at this moment. So using this video, I hope you should have gained a better idea on how to mark the direction or how to understand the direction of friction. At the same time, what is the 3 types of friction and what do they actually mean? Thank you.